Hello, everyone, and good afternoon or good morning, depending on what part of the country you are in. And welcome to another Paperless Lunch and Learn. Today's topics will be the 5 examples of how you can boost efficiency out on your shop floor through the use of IoT. The 5 examples that I'm going to go through are, sorry, a little technical difficulty here. There we go. Quality and purchased items. Then we'll talk about production, downtime, inventory, and then quality again, but more so from a work in process and finished items standpoint. You think about today's shop floor, it's much different than what we've seen in the last decade or the last, 2 decades or 3 decades, right? The Internet of Things isn't a new topic of discussions. Connected things are everywhere, from refrigerators to watches to cars, changing interactions with friends, family, coworkers. While IoT discussions often center around that consumer usage, like things I just mentioned, there's great potential for adoption for the manufacturing shop floor. You think about today's manufacturers and things that they're trying to do, it's really doesn't look like it did in the past, where the typical image was, a lot of repetitive assembly lines, right? You think of Ford, you think of, circuit boards and things like that. Very, very, very repetitive type of things, making the identical part over and over again. Well, today has kind of changed everything, right? And modern shop floor is really kind of a collection of technology and sensors and electronic controls and automated equipment. And these interconnected devices really drive efficiencies, quality, and flexibility. So you think about technology, sensors, controls, and all of those things, and they're out there for reasons, right? And it's amazing the number of plants that I've gone to over my 30 years in the industry to understand what the changes have, what changes have come about, not only with robotics, right? Robotics was obviously huge, but that was, 2, 3 decades ago. Now it's really taking all of those robotics and all the information and trying to communicate as much of it that you can, or really just picking out the things that are important that you want to communicate to whomever, whether that's people on the shop floor, whether that is people in the office, or your vendors or your customers. This age of communication that we live in today is where this IoT has come and said, all right, it's not only connecting my phone to my car radio through Bluetooth, but it's also connecting my robotic machine that either is manufacturing something or testing something or producing parts to my shop floor personnel, as well as my management group, team, as well as my customer base or sales team. So it's a full realm of connectivity out there. And you're thinking about the old paper-based system, right? You've got this though, where you've got paper and people were writing on it. It had to be distributed on the floor. Obviously, there's a lot of potential for errors in any paper-based system, whether you can read it, whether it gets lost, whether it gets smudged, duplication of paper, right, and all of those things. And then you're thinking about on the back end, somebody has to take that paper and key it into some system in order for you to get some use out of it, right? It's good in media. It's kind of like your newspaper. It's good today, but what we all do with the newspaper, right? We take it and read it, and then we throw it away. Well, what if I want to understand, what happened 3 days ago, or who won the World Series last year, things like that. We want to be connected, so we grab our smartphone or our tablet or our laptop, and we go look at that information. And that's what you get out of this old paper system, is that it's good for today, but if nobody keys that into any system, or even if you scan it into some system, it's still not good, because you want to be able to interrogate the information that was collected. I want to know what the result was on a quality test. I want to know what it was compared to an expected value, all of those things. So, factory productivity continues to rise, as plants produce more with ever increasing efficiencies and quality. Connecting these tools and machines are a key part of making those gains. So when you replace that old paper system, with a more electronic system, these are just some of the benefits that you're going to see. You're going to see accuracy, simplified entry, real-time information, communication, traceability. All of those things real-time benefits out of an application that is connected. You think about communication, I can alert somebody and notify something when something's been completed, or I can alert about a problem that is popped up out there on the shop floor. I think about real time. It has to be real time, right? Because that's what I just kind of explained with how we live with our smartphones and tablets today. I want to know the information right now. And that same approach goes for the shop floor. Accuracy, that paper-based system is just prone with errors or potential errors out there. With a more electronic system, you're reducing or eliminating many, if not all of those errors out there on the shop floor. And then traceability is the last thing I kind of went through as far as, you want to be able to capture this information to be able to go back and look at, do I need to change my processes? Do I want to know how many pieces I produced over the last quarter or last month, et cetera? Do I want to know what type of defects that were found for the manufactured parts that I made, or the defects found for the purchase parts that I made? All of those things are part of the traceability that gives you the tools and information to make better business decisions, to obviously go on that continuous improvement path to say, where do I want to improve and how do I want to improve things? So let's jump into our examples here. The first one I want to talk about is just quality purchase, right? So we talk about purchase parts. Most every manufacturer that I've ever gone into has purchase parts, and you're going to do some testing against those purchase parts. And it can either be tested by a human or tested by a machine. And you think about the gains that you get here. Now, maybe I'll just give you one example that I've run into is, like, let's say I'm a metal manufacturer, or I'm actually utilizing metal in my manufacturing process. Maybe I want to do a hardness or tensile test on that incoming part, and maybe there's obviously different types of tests that you can perform. A Rockwell test is just one of those. Well, that Rockwell test can be automated through Internet of Things, where you can actually perform that test through an automated device and then automatically record that information into your database. And once it's recorded, not only is it there for history, but it's there immediately to be able to alert and notify somebody if something went wrong. And that's both internally and externally. You can notify your purchasing department, or your material manager, or whoever it may be, inside your four walls, to say that I've got a problem with this material and I need to buy more. But you also can send that information directly back to your vendor, letting them know that the parts that they just shipped to you were not in conformance with your expectations. Very, very powerful. And again, you can do this both in a human aspect, and you can also do it from a machine. Human is kind of like someone saying, I'm all right, I'm going to scan something, right? Like this person on my little image here is scanning something. And maybe that is also, from a paperless perspective, saying that it's going to automatically populate this field on my paperless screen here, where it's giving me the value of 6.34 from the device that was used to do that measurement. Maybe it's an inside diameter measurement, right? And now again, there is no interaction from the human to actually touch the screen. So that's where you eliminate the potential for error, someone fat fingering and typing in 6334 or something like that. So you eliminate those errors up front, which makes yourself much more efficient. And again, this is obviously captured information that goes into a database. Now, another way that you could have it is you could have it done through a automated machine testing unit, where you have a machine test unit that is set up, and you place your item that needs to be tested in front of it or on it. It goes through one or multiple tests for that specific item, and it captures all of the captures all of the actual results. And again, that information, because it's in a database now, can be connected through an Internet of Things, quote unquote, type of application that says, who do I want to communicate this information to? Or what do I want to trigger based on the output of this information? Maybe I want to trigger a non-conformance report that gets generated, and now it gets emailed out to my manufacturer, my quality engineer, or my material review board, and they're looking at this non-conformance report, and they send out another manual, or they send out an inspector to go verify whether or not the testing machine performed what it was supposed to do, or if it actually didn't perform it and it had to be retested. So a lot of good information can come out of that, connectivity through a quality type of event. And again, these can be human or they can be machine. You think about the Internet of Things, right? Going back a little bit here, it's really the communication of a number of different systems or applications with data between them two, right? I gave you guys my example earlier about my smartphone, and I want to know who won the World Series last year. There's some human interaction there, right? Where I grab my phone and I type on it to actually say something, or maybe I grab my phone and use a voice-activated search capabilities. But there's some human activity or human interface there. But again, you can also eliminate that human and say, I've got a machine that's going to test everything, and it's going to publish those results and put them into a database. Then another machine is going to actually pick up that information and go trigger something. So there's both aspects here. And again, it's the connection and communication of information through different systems and different tools. My second example here is production. One simple example of production, because there's a lot of things that you can actually communicate, but one simple one is good pieces and scrap pieces. The picture I have on the screen here is one of our customers who is actually we put a sensor on their machine, and this isn't a blurry picture. This is actually a clear picture. They manufacture paper goods. So you can imagine the speed at which their machines run, which is pretty fast, which is obviously blurry to the naked human eye, right? So this sensor that is actually circled on here is actually counting the paper that is, or sensing the paper and counting it as far as the amount that is going into the machine, as well as the amount that is coming out of the machine. And they are actually getting the input feed and the output feed. So therefore they can do the math to figure out how many good pieces were made, as well as how many scrap pieces were made. No human interfaces here at all. This communication is obviously not only within the paperless application, but can be communicated to any other system through IoT types of usages, where I can say I'm going to talk to your ERP system and create the necessary transactions for the manufacturing order that was released to actually produce these good pieces or bad pieces. But a lot of information is good just from that, these two little sensors, right? Incoming sensor and outgoing sensor. It can produce, reports that say, how am I running compared to what I'm expected to run? And you can have dials and dashboard types of capability that says, I'm in the green, or I'm in the yellow, or I'm in the red, based on what's expected for this job on this machine. You can also kind of put them into a dashboard that doesn't have dials and triggers, and it has more information about, order quantity, completed quantity, remaining quantity, et cetera. But again, this is all being fed from that sensor, which is your IoT type of interface, right? You can also, have different types of information for, activity or performance or efficiencies or scrap. These are all things that can come automatically from that sensor or that connectivity to that machine that's running that job. And in this example, it's a sensor. It could be a PLC that's connected to the machine. It could be a CNC machine. It could be a lot of different types of machines and a lot of different types of sensors. But again, the point here is that it's collecting that information automatically. It's connecting it real time. It's accurate as far as what it's collecting, and then it's broadcasting all that information to a number of different systems, your ERP system, your other shop floor system. Maybe it's creating alerts and triggers to supervisors or operators of that machine that says, hey, I'm running at 60% of my expected run rate. There's a problem here. I need to actually change something. So you can see the statuses and activities and efficiencies and everything else. Excuse me. My next example here is downtime. One of the most important things about any manufacturer is understanding, the utilization of their machines, as far as, is the machine not running Are there no parts going through that machine? Do I have some type of machine failure where it's offline? I have no power. There's a lot of different reasons, but the main thing here is that if your machines aren't running, you're not producing pieces, so you're obviously, either not completing something to the customer's expectation, or you're underutilized, right? But again, downtime is a very negative thing in manufacturing. You want to keep an eye on it. So you can put, again, sensors on those machines to indicate whether parts are going through them. You can even put a sensor on there to say I've got voltage or I've got amperage. A lot of different reasons can indicate why that machine is down, or you can set up different things within your PLCs or your sensors to say, all right, I only want to indicate this machine is down if I have no voltage going to it, that's something like that. Or maybe it's I have voltage, but I have no parts running through that machine. So a lot of different things can be, again, indicated through a sensor for downtime. Another great example, a number of our customers are actually implementing, different types of sensors or capabilities to understand if their machines are down automatically. And then you think about all the benefits and efficiencies you can get, because if a machine is supposed to be running and it's not running, and I get an immediate update, like on a dashboard like this, which is a 55-inch monitor out there on someone's shop floor. The solid red line means that this machine is currently down for whatever reason. All the other information is actually above it, just saying that I'm running jobs and here's what I'm expecting and here's the performance of stuff. Paperless also has some different dashboards that you can look at, and those downtime events can come in forms here where I can say I have two machines that are down, assembly 7 and assembly 8. Assembly 8 has only been down for 2 minutes, but assembly 7 has been down for 12 minutes and 27 seconds and turned red. So you can actually turn colors based on the amount of downtime that has already been accumulated, kind of giving you that visual indicator that something is wrong and it's crossed a threshold where you feel comfortable or where you want to have somebody take action upon it. And then you can also have a downtime chart that's more historical. We talk about the analysis and continuous improvement part of any manufacturer. And if I look at my downtime for each and every work center out of my shop floor, I can see on the left-hand side here, assembly area 3 has been down for about 1,200 hours. And that's the one that's kind of stands out to me that says, you know what, I need to investigate into why it's going down. Is it the items I'm running on? Is it the personnel that I'm running on it? Is it the machine itself? The tools that I'm using, or the dies, whatever it may be, incorrect for that type of machine? But at least you have the information now that says this machine is the one that's going down the most, and you can actually drive into the details to see why it's going down, understand what jobs were running when it went down, what items were being used, the tools, et cetera, et cetera. All that information can be captured automatically through that IoT type of infrastructure to be able to give you that information to better or to improve your processes and everything else. I'm going to pause right here for a second, and as I pause, I'm going to actually put out a couple poll questions. And poll questions are very simple. They should just pop up on your screen. You can actually say yes or no to each one of those. So the first one I'm going to trigger off here and launch. Oops, is have you thought about IoT on your shop floor? And just thinking about it, is it something that's crossed your mind in the past where you said, I wish I could get something like this? Because I don't know about you guys, but my brain really starts to go crazy when I have my phone in my hand and I pick up a new application. I'm like, oh my gosh, this would be very cool. And I try to apply it to my real life and say, how can I make my life more efficient? I use a calendar for my family, and everybody updates the calendar. So I know when work schedules change or where there's a doctor's appointment, et cetera. That information is just critical. So it's always, in front of me. The second question I'm going to ask is, do you have an active plan to implement IoT out there on the shop floor, whether that is currently underway, meaning that I don't want to say that you have an IoT infrastructure in place and you have the sensors or PLCs in place, etc. But just the thought and saying that, you know what, I'm going to kick this off, and maybe, just like my downtime chart is I was showing you, there's one work center that is always going down. I want to figure out why that one's going down. Just like with IoT, you don't say I'm going to implement IoT across my entire factory all at once. You're going to pick and choose the areas that best make sense, but more importantly, that gives you the most return on your investment. And then my last question out here is just, are you guys interested in learning more about IoT and just having a discussion as far as where you could implement it, how you could implement it. Some of our existing manufacturers have very outdated machines, and they think, well, it's an outdated machine. There's no way I can actually, have a PLC communicate to this, or I was told in the past that I can't have a PLC implemented with this. The example I gave you before on that machine with that sensor, that was not going through a PLC on the machine at all. That was an external sensor that was put on that machine to indicate how many pieces were coming in and how many pieces were going out. So it doesn't have to be a the machine has to be 2000 or above, right? It could be a 1932 machine that you want to put some type of IoT communication tool on there for activity on that machine. All right, I'm going to close those polls and come back to the PowerPoint session. My next example is inventory. You think about inventory. The inventory has many different levels. The first one I call is interactive, right? Where it's communicating to material handlers for really what was picked, where to pick it, and then what was picked. So, what do I need to pick, right? Where do I go get it from? And then what was actually picked. So in my little image here, it's actually a person that is getting some information for what to pick. And then when they pick it, they're going to scan it and communicate that it was picked. And that can obviously, bubble up and can go into all the other applications that's connected to it. Then we have kind of more of an automated sensor type of thing, right? Where I've got a weight sensor on these bins that are on the wall that's actually going to indicate if material is low, and that when it does get that indicator, it's going to go and trigger a replenishment request. And again, this replenishment request could be internal or it could be external. So that weight sensor, I could have a point of use location out there on the shop floor for my commonly used items, and have these sensors out there. When I get down to 10% left in that bin or 0% left in that bin, it automatically goes and triggers that material handler that says, I need more of these parts. So there's no human interaction there at all, besides the material handler actually getting the trigger and going and grabbing those parts. And then the last one here, I think about totally automated, is the AGVs, your automated guided vehicles out there, where they're getting some type of trigger to go get material and take it to a specific location. So my last example, when I have this weight sensor, right, that sensor could trigger an AGV that goes and grabs the necessary items off the shelf and brings them back out to that point of use location. So you can go, and this is a really good example here, because you can have many different levels of this Internet of Things usage, right? Where you can have humans still involved, you can have no humans involved to a certain level, or zero at all costs, with the AGV being triggered by a weight sensor on a bin. So a lot of different things that can be done there. Last one is, my last example is quality. You think about quality, right? And a good example here is about connecting, a tool like a torque wrench, to the assembly of a complex part, for example. When I connect that IP torque wrench, it captures torque applied to that specific part, the specific wrench that was used. It also captures when that wrench was last calibrated, the employees who did it, et cetera, et cetera. Faults can be detected in real time, and I can even if there, those faults were missed for whatever reason by the operator that was supposed to be, seeing a red light pop up or whatever, I can still go back and trace those faults through historical information, because all that information is gathered and stored in a database, so it's obviously traceable. But another good example here for, an IoT type of application is having this torque wrench. I want to make sure all my bolts or screws are torqued to the right poundage, so that I'm producing quality items and I don't get any rework or returns or anything like that. You think about IoT, and then, there's some things here that I just want to recap, from a benefit standpoint. And the new term out there is kind of industrial IoT. But again, the benefits are, making sure that you get accurate information. It's simple, which means that, whether that user is involved, it's still simple to them, maybe one click or one scan, then that information is captured. Or in the case, obviously, of nobody interacting with it, then it's obviously even simpler. It's all real-time information, not only to the application that captured it, but to all other applications that can communicate to it, which is obviously the communication part. And then the historical traceability of this, not only in real time for what's going wrong, what's going right, but also from a historical standpoint to say, where do I need to put my improvements, etc. I grabbed a chart from Aberdeen, and just to, a good example, and this chart is actually a couple of years old, but it just gives you an idea of the benefits and what you're going to get out of some type of IoT infrastructure out there on your shop floor. Reducing costs 55%, improve operational equipment uptime and availability, your downtime stuff, right? 51%, increase operation speed, your productivity and your efficiencies, improve quality of your product. And I think this number is almost a little bit skewed. It's probably just internal, that 36%, because internally maybe I've improved my quality by 36%, but you think about what that's done to your customer base, right? They have less returns, they're more confident in buying parts from you, et cetera, et cetera. And then improving safety, 23%. So that's from Aberdeen. Like I said, that chart's a couple years old, so it could even be increased, since then. With that, I thank you for your time today. If there's any questions, I'll open it up for questions. I got one question, and actually I think I kind of answered it a little bit already. It was, what types of devices can you use to collect information from machines? There's it's almost, I want to say endless, but there's a plethora of devices that you can use. Some have, integrated gateways where you can put sensors and configure those sensors to record any number of different pieces of information, like temperature or speeds or a poundage for stamping. There's a lot of different sensors that can be done. But again, in my example that I showed as well, even if the machine doesn't have a integrated gateway or PLC that can be attached, you can have an external type of sensor that can be put out there. The weight sensor is an external sensor. That sensor I showed you, counting pieces going through it, is an external sensor. We also have another customer that they make sensors that are really take pictures. So it's taking a picture of the parts that are flying by it. So you could use that to get an image of everything you manufactured. One of the applications that we've done for a customer is we put that sensor in that was taking a picture of a 2D barcode and deciphering the information on that 2D barcode to then actually do additional things, trigger additional events. Good question, though. I don't see any more questions out there. Again, thank you for your time. Be safe.